All right, let's talk negative exponents. All right, we're going to make this quick. We're going to skip the explore section for today. Yet again, I think it's a little bit confusing and a little weird. Doesn't really apply to what we're doing right now, or I don't think so. The application is a little bit of a stretch to me. Okay, so we're going to talk about the discovered. Today we're talking about negative exponents. Do you understand what a negative exponent is, means? Do you understand that does a negative exponent necessarily indicate a negative number? And do we know all the basic exponent rules? Okay, because we're gonna continue to practice these basic exponent rules today and tomorrow, or excuse me, next time I see you. All right. So let's talk to it. So there's all this writing about negative exponents. Okay. A big thing, I want you to take a look at this. Another way to simplify is use a quotient rule, and we want to subtract, and we would get x. The first explanation said just to cross it off. If you look at the bottom of page 476, right down here. All right. No, you're good. What's up? I could use the cross off method, but really what we're doing is we're subtracting 4 minus 2, right? We're subtracting. Okay. Again, you could use the quotient rule, okay, which is the actual exponent rule where we subtract our exponents. All right. I always say in my line of thinking, I think it's always easier to think about it to subtract from this, starting with the bigger exponent. The bigger exponent is 4, so I would do 4 minus 2. I want to do 2 minus 4. Maybe that wouldn't make sense. But anyway, another way to see why this equation makes sense is to look at the pattern formed by decreasing exponents. All right. Yada, yada, yada. If you increase our exponent, my numbers will increase. If I decrease, the numbers will decrease. Okay. You notice that each time the exponent decreases by 1, the result is divided by 3, because really what we're doing is 3 to the first power is 3. 3 to the second power is 3 times 3. 3 to the third power is 3 times 3 times 3. So we're always multiplying our result by 3. Is divided by 3. So if I have 3 to the 0 power is 1, so in 3 to the negative 1, dividing by 3 again, that's where the 1/3 comes from. 3 to the negative second, I divide 1/3 by 3, which is the same as multiplying it by 1/3 as well, which would give me the 1/9. Okay, that kind of is where it comes from. That's what the book is trying to say here. So a negative exponent always indicates the reciprocal, and that's the word we've used before. Reciprocal of x to the negative a. So x to the negative a is reciprocal of x to the a. That is, x to the negative a is 1 over x to the a. So to make a negative exponent positive, I take the reciprocal. Okay, I take the reciprocal. So what does that look like? Well, I have 2 to the negative 4th. To make that positive, I do the reciprocal, or some people just say flip it. Okay. There is a difference between B and C, right? Although it may be hard to see. Too many C's going on. There's a difference between these two parts. Okay. In part B, it's saying, hey, this entire thing is negative. So I make the entire fraction negative after I flip it. In part C, it's saying just the 2 is negative. So if just the 2 is negative, I want to bring the negative with the 2. Because if you plug this into your calculator, you'll notice a difference between the two. And actually, why don't I just do that for you? Let's take a look here. I have negative 1 over 2 to the 4th. I get 1/16. Now, the good thing about the Desmos calculator scientific calculator, is that you just click and it converts it to a nice fraction for you. Then I have 1 divided by negative 2 in parentheses. Look, click that button. Hey, it's a fraction. Look how these are different. 1 is negative and 1 is positive. Why is that true? Because when I do negative 2 to the 4th, I'm doing negative 2 times negative 2 times negative 2 times negative 2. So I have an even number of 2's, which means my entire the whole number will be positive. It'll be positive. So let's keep going. We're having fun, I can tell. We can use the definition of negative exponents to rewrite 5 to the negative second as 1 over 5 to the second power. All right. We write 1 over 5 to the negative second it becomes just 5 squared. So if something's in the denominator, we want to make it positive, we flip it to the top. If something's in the top, we want to make it positive, we flip it to the bottom. Okay, rewrite the following with only positive exponents. Well, in part A, only x has the negative exponent. Only thing with a negative exponent. So y, x goes to the bottom, and that's it. Just x goes to the bottom. Here, in part B, and that's your final answer, sorry. In part B, you'll see that both x and y have negative exponents. That means both x and y need to flip. That means I need to write y on the top and x on the bottom to make our exponents positive. Okay, the how it works is great, and this is one I definitely want to talk about. All right, these are our exponent rules, all right, that we need to, maybe have a refresher on, or maybe remember a little bit. Okay, if I have two bases that are the same being multiplied together, I add my exponents. If I'm doing division, I subtract. I think of the division, the fraction bar is one big subtraction sign. Anything to the 0 power is 1. Power to a power, I multiply, and I can also distribute that power like you see here. Same thing with number 6 as well. These are a lot of rules, but we'll just we'll practice it, don't you worry. A negative exponent to make it positive, I put on the bottom. A negative exponent that's already on the bottom, I move it to the top. Technically, you can think about this as being over 1. That is true, but we don't always write that. Remember, we don't always write that. So I'm going to stop here, okay, and then we're going to pick up with number 4 as a whole class. All right? Actually, you know what? We can just do, let's do A, B, and C. 4a, 3 squared is 9. 3 to the negative second is 1 over 3 squared, which is 1 over 9. 1 over 3 squared is 1 over 9. And I want to pause there. We'll stop. Don't have too much fun. Here we go.